Welcome to VINDAL'S Concept and Math Physics. Please, if you are seeing this for the first time, then you know that there is another experiment I have done on this same number one. I don't want to leave any stone unturned. I have realized that what they do is, if you do only one, I am doing this. This is the second one. Two. So this is the second one I'm doing. If you are seeing this one, then you need to look for the other one I have also done. These are the meter rule. These are the apparatus giving meter rule, rotor stand, stopwatch, mass hanger, clamp, spiral spring, pointer, set of masses, and plasticine. Now, the first one I did, I was able to generate the extension, but here I'm also going to consider the extension and measurement, anyhow they want us to do it. Now, this is how I'm going to set it up: the mass hanger, the spiral spring, the clamp, the rotor stand, the meter rule, and the pointer. So what do? It says suspend the mass hanger on the free end of the spiral spring and note the position of the pointer. So we have to note the position of the pointer. Then pull the hanger gently downward and release to set it into vertical oscillation. So pull it a little small. Determine the time T for 20 oscillations. Evaluate 20 oscillations. Evaluate the period T of the oscillation. Also evaluate T square. Remember that when you get the time from your stopwatch, it's not the period. But to get period, you now say that T is equal to that time you got divided by the number of oscillations. Sometimes they may give 10 oscillations, sometimes they may give 20 oscillations. Anyhow they want to do it, you are already prepared for it. The next one is evaluate T square. Repeat the experiment for mass 50, 70, 90, 110, and 120. In each case, evaluate T, capital T, and T. The time for 20 oscillations, period of oscillation, square of the period. Tabulate the region. Plot a graph of T square against M. Determine the slope and the intercept I on the vertical axis. Evaluate K, this over this. I will tell you what this K is, and then they also say define the Young modulus. Okay, before I go into the practical, into laboratory to carry this experiment, let us apply into this. Let us find out what is this. Why are we evaluating this? Let's find out. Okay, I want you to know that I have explained this. I want you to know that T is given as 2 pi L over G, But also know that T, one is for simple pendulum. This is for simple pendulum. I have done a derivative. I have proven this formula. It's already the video is already in my channel. You can watch how to prove this, how to do the experiment and come up with this. Then another one is T 2 pi is equal to mass over K. All right, this is another formula. This formula is for the spring, which we are doing here. You also have a proof for this already. Now, in this case, if you look at this very well, you realize that if I square both sides, if I square both sides, you will see I will have T square is equal to 4 pi square M all over K. You know what I mean by that? Because these two will affect 2, it becomes 4. And these two also, which is a power for this pi, it becomes pi square. Then this is what you have. Now, if you check very well, we are going to plot a graph of T against M. Now, when we plot a graph of T square against M, you realize that T square is equal to 4 pi square over K times M. And then this is what we have. Now, I'm going to compare this with a straight line equation. I'll say y is equal to mx plus c. You realize that this y is a vertical axis, which is y, and this x is horizontal axis. If you have a graph, then this slope is given as m, which is the gradient. The slope is the gradient. So if I compare this to this, then I'm going to plot a graph of t square and then m on the horizontal axis. Then I don't have any constant, but the constant can take any value, which is c. You realize that this value is corresponding to m. Therefore, the slope you are going to have is going to be given as 4 pi square over k. Is going to be our slope. So that is going to be our slope. Therefore, if I do my experiment and get s equal to 4 pi square over k, then they say I should evaluate this. What is that k? The k there is our spring constant. Then I'm going to say that k, which is spring constant, is 4 pi square all over my slope. In order to find our own spring constant, I'm going to do 4 pi square all over s. Therefore, what they want you to evaluate, they want to know your spring constant. And that is gotten through your slope when you find your slope. Okay, so this is the analogy for this expression. And another one I'm going to talk about is Young modulus. Young modulus is defined as the ratio of stress to strain, and the force constant is same thing as this k, which is called what do you call that? Force constant. Thank you. Let's go to the lab. I was explaining this. So if you plot a graph of y against x, you have the slope is m. If you also plot a graph of t square against m, you have a slope of 4 pi square over this. So this is what I was trying to explain. Okay, let's start the experiment. If you look at the position of the pointer is at no. Okay, if you look at the position of the pointer, you will notice the reading is 63.2. Now, as that place is 63.2 now, and this is called the initial position. This is my initial position. So the first thing I'm going to do is to, according to Ohm's law, according to Hooke's law, not Ohm's law, according to Hooke's law, when I gradually slot in another mass, you see what has happened. There is a change in the length. The length is no longer 63.2, is now at 63.7. Something has changed. So you note the change in the length, which is called the extension. And that extension is going to be 63.2 minus 63.7. So whatever you have, or simply put, the bright thing is to say 63.7 minus 63.2. So which is going to give you 0.5. That is 0.5 is going to be your extension. Now, according to our experiment, the next thing I'm going to do is to take 20 oscillations of the mass, very small. As it is oscillating now, I'm going to start with my stopwatch. So I'm going to take first 20 oscillations. Now let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. No. That's not correct. So I'm going to take my first 20 oscillations. But remember, you will not pull it so much, gradually. So you are going to move fast with the movement of the oscillation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that is the first 20 oscillation. And I am going to record it with what I have here, which is 4.9. My T1 is 4.9. 4.90. I will go another one for T2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And this is 4.9. Also 4.9. So I'm going to take another oscillation. But before I go into another oscillation, I will now slot in 70 by putting 20 to 50. Now I have 70 MB, that is 70 grams. So I'm going to take another 20 oscillations. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And if you look at what I have here, approximately 5.7. And that is my T1. So I'm still going to do another one to have my T2. T2, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 22. Oh, shit. Should be 20, and I continue. Okay, let's redo it. However, it should be very small selection. I think this is too much. No? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And that is approximately 5.7. 5.7 again. T2. Now I'm going to slot in another one, and this I've slotted this is another 20, making 20 plus 70 is going to be 90. So we have to reset our stopwatch and go back to the next again. Then I am going to, okay, the more the mass, the longer the period. I mean the time, the longer the period. Okay, let's go. 1, 2, 3, 4, 5, 6, 7. No. Let's go. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is 20, which is approximately 6.7. 6.7. 6.7. So I can continue with the oscillation I'm seeing there. I can use this sum for the next oscillation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And what are you seeing? What are you seeing? Approximately 6.5. 6.5. So 6.5, 6.6, anyone. So I'm going to slot in again. By slot here now becomes 110. Now with this 110, I'm going to, that's too much. I think that's too much as well. Just small. No. Don't let it wumble. Just okay. Let's manage this. Okay, now let's go. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And the time you are looking at is almost like the same thing as that of. So I'm going to redo it because it is almost coinciding with the one of 90 grams. So I'm going to redo it. So I will go back. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's almost okay. It's giving me 7.1. 7.10, which I know that value will cause a difference in our graph, which is normal. That point may shift. So I'm going to press here. When I press here, it goes back to the original, which is reset. So I'm going to also take another 20 oscillation, and I'm going to stop here. The other one, you can manipulate it. I'm also going to do a video on how you can manipulate this without doing the whole of the experiment using formula. And that video will be coming shortly after this one. Now let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You see, it's not lying. It's almost 7.1. But this one I'm having about, look at it, 7.2. 7.2. Okay, we are done with our graph, our experiment. So that is what you are going to do until you do the rest. So let's go check our table of values. Work out the rest of the table. So let's work out the rest of the table. Now, T1 plus T2 over 2 means this plus this divided by 2. So the answer is going to be 4.90. This is also going to be 5.70 because nothing changed. But this is also going to be 6.7 plus 6.6 divided by 2, which is 6.65. This is also going to be 7.1 plus 7.2 divided by 2, 7.15. This is 8.5 plus 8.6 divided by 2, which is going to give me 8.55. Right. So with this value now, I'm going to divide this by 20. I'll write the answer here. Divide this by 20. I'll write here. So fill this column. So 4.9 divided by 20 is going to be 0.245. 5.7 divided by 20 is 0.285. 6.65 divided by 20, 0.333. 7.15 divided by 20, 0.358. 8.55 divided by 20, 0.428. So this is the t, which is called the period. This is the main period now. Y t square, I'm going to square these ones, which is 0.245 squared. I'll make it 4 decimal places, 0.0600. Then 0.285 squared, 0.0812, 0.333 squared, 0.110809. 1, 2, 3, 4. Please, let's work together. Then 0.358 squared, 0.358 squared, 0.1282, 4 decimal places, 0.428 squared, 0.1832. So this is the t square. Now, according to the question, okay, you're welcome. Let's do the graph plotting for the table of value, which is pasted on the screen. Someone commented that I should always take it slow, and I'm going to try my best. But remember, the length of the video is going to be very long. But let's see how it goes. I'm going to take it slow. Now, I have drawn my vertical line, and my vertical line I've labeled t square, which is the quantity I'm plotting, and then the unit s square, which is also what I've recorded here, because you must write the quantity and the unit. And the title is a graph of t square versus m. Then on the horizontal axis, I have written m, which is the mass, and the gram is the unit I am plotting it. It's not you are not going to take SI unit here. You are going to use that unit you are using to measure your graph is what you are going to use to write there. And the next thing WAEC will want to expect from you is the unit you are using to plot, which is very important. 2 cm is 20 units on the x-axis. Oh, no, that is wrong. It's not. Yes, 2 cm is 20 units on the x-axis. That's correct. And 2 cm equal to 0.02 on the y-axis. So, like I said in my last video, what is 2 cm? 2 cm means this is the beginning, which is 0. If you count 10 lines, you meet 2 cm. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 2 cm. All right, so this is going to be 20 plus 20, which is going to be 40. 40 plus 20 is going to be 60. 60 plus 20 is going to be 80. 80 plus 20 is going to be 100. 100 plus 20 is going to be 120. 120 plus 20 is going to be 140. So that is the end, because your table of value, as you are seeing on the screen, stopped at 130 gram. So that means it's advisable to get to 140. Come in. Okay, so on the vertical axis, every 2 cm is 0.02. So this is 0.02. The next one is going to be 0.04. The next one is going to be 0.06. This is going to be 0.08. If you add another 0.02, you're going to have 0.1. Then if you add another 0.02, you're going to have 0.12. So this is going to be 0.14, and then this is going to be 0.16, and this is going to be 0.18. Now, why did I choose this scale? See what I did. First, I counted from, this is 0, work with me, this is 0. This is 1, 2 cm, this is another 2 cm. So I counted, how many 2 cm do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 2 cms. If you look at the table on the screen, you will see that under t square, because this is t square, under t square, the highest number there is 0.1832. I'm sure you are seeing it, 0.1832. That 3.1832, if I divide it by the number of lines here, number of 2 cm, like I counted it to be 9, we are going to have 0.1832 divided by 9. You are going to have 0.02. That is the reason why I was able to get 0.02 here. It helped me to get to that point. The same thing I did here. But this one, I was a little, because this one is not hard, I just decided to go with 20 so that I will be able to get to 130 somewhere there, because the highest is 130. Or you can also say, if you have 130 divided by how many lines? 1, 2, 3, 4, 5, 6, 7. 7 lines. The highest number on the gram column on the table of value you are seeing on the screen is 130. So if you divide it by 7, what do you have? Say 130 divided by 7. You're going to have 18. So I approximated my own to 20. And that was why I got this CM. Now let's start plotting. The next thing you're going to do is very important. And that is going to be, this is where the major work comes in. You will ask yourself, if 10 lines make 0.02, what will one line be? One line is going to be 0.002. I mean, if you divide this by 10, you're going to have 0.002. That 0.02 is the meaning of each small line. This one is going to be 0.002. This is going to be 0.002. This is going to be 0.002 throughout on the vertical axis. While if you come to the horizontal axis, what does each small line here mean? If you say how many lines make this 2 cm, is 10 lines. 20 divided by 10 is 2. So this small line means 2. This is another 2, which is 4. This is another 2, which is 6. This is another 2, which is 8. This is another 2, which is 10, until you reach 20. So now that you know what each line represents, your plotting of graph is going to be very easy. You understand? So that is the major work you should do while plotting graph. Now let's plot the first one. When it is 0.06, the mass is 50. Now, if this is 40, how do you get 50? Remember, each line means 2. 42, 44, 46, 48, 50. This is 50. So you keep on tracing it until you have 0.06. You see? Therefore, this is where the 0.06 is. This is 0.06, okay? 0.06 is here under 50. Now, the next thing is under 70, you have 0.08. Under 70, you have 0.08. If this is 60, 70 is in the middle. And let's go to 0. Look at it. It's here. This is under 0.08. Because I am not going to plot all of them. I decided to be plotting 2 decimal places, okay? It doesn't change anything. It's still the same. Many students will always ask, is it 2 decimal places or what? So you can plot 2 decimal places. That will be fine. All right? So the next one is under 90. Under 90 is 0.11. 0.11. Now the question is, this is 90. And this is 0.1. How do I get 0.11? That comes to the measure 18. I want you to use your calculator if you can and work with me. Let us get 0.11. Okay. Now remember that each line on the vertical line, can you remember? Okay. Each line means 0.002. Each line on the vertical, I mean, this small line is 0.002. This is 0.002. This is 0.002. This is because, why? Because 2 cm means 10 lines. And that 10 lines is equal to 0.02. If you divide 0.02 by 10, you are going to have 0.002, which represents its smallest line or division. Now we are going to be adding 0.002 on this one to get 0.11. Let's go. 0.1 plus 0.002. I want to work it easily so that you can get there. So the first one is, if you have your calculator, you have 0.102. If I also add another 0.002, I'm going to have 0.104 plus 0.002. I'm going to have 0.106 plus 0.002. You have 0.108 plus 0.002. You have 0.11. Now the question is, how many lines did you add until you get to that one? But see the fastest way to do it. You know that you are looking for 0.11. Say 0.11 minus 0.1. You are going to have 0.01. Let's do it. You are looking for, in your table of value, you want to get 0.11. Say 0.11 minus 0.1. What do you have? You have 0.01. Now, since each line means 0.002, you are going to say 0.01 divided by 0.002. You have 5. That means you are looking for 5 lines. So from this 0.1, count 5 lines. You have 1, 2, 3, 4, 5. That is where 0.11 is. So I'm going to trace it to 90. That was a very long one. This is the time it takes. Okay, so I have this place now. That is 0.11, which corresponds to 90. The next thing is 0.12 under 110. 0.12. I'm going to say 0.12 minus. Oh, 0.12 is already there. This is 0.12. But, you know, you are seeing 0.12. Some people will say, looking at the table of value, should we make it 0.13? If you make it 0.13, there is still not going to be issue. I think that's the best thing to do. And that will be under 110. So let's say 0.13 minus 0.12. Of course, you have 0.01. Now, that 0.01 you have, divide it by 0.002. Divide by 0.002. you have 5 lines. So you are looking for 5 lines from 0.1 to you have 1, 2, 3, 4, 5. Under this place will be 110. There are simplest way to do all these things, but I'm showing you the analysis. So that is where that one question. The next one is 0.8. 0.18 is under 130. If this is 110, this is 120. 130 now is going under 0. This place. This is 0.18. So we are finished plotting our graph. And of course, if you look at that very well, you realize that that number is too far from the other. And that number, I got it by manipulation. So if you check, maybe we would have said 5 point something. It's all right. Let's join our graph and find the slope. And lastly, let us join and see where our graph will be like, how it will be like. So I'm having 2 lines joining. This is not the best line of fit. Okay, this one fall here, this one enter, this one fall here, this one enter. No, it can't be like that. I would prefer it goes this way. This one fall this way, 2 lines enter, this one fall here. Yes, correct. This is my line, my best line of fit or line of best fit. This is the line that best fits this graph. Right? This is because if you check very well, this fall in the left hand side, this enter, and then this fall in the right hand side, and then this one fall this one. So I prefer this to be my line of best fit. Okay, the next thing I'm going to do now is to choose my slope. What am I going to do to get my slope? I will look for any line that makes a good coordinate and that will give me a bigger triangle. I am choosing this point. Look at this point. I am choosing this point. This point entered very well. So it enters very well. And then I will choose another. This is another point that entered very well. I will choose these 2 points and I will form a triangle with these 2 points I have chosen. And this is going to be. Use broken lines. It makes it. That's how I likes you to do it, because it's not the line from the graph. You are the one forming it. So use a broken line. Oh, sorry, I think it's full triangle. Use a full triangle. Make a full triangle from that line. Form a right angle triangle. Not broken line. I will show you where to use that broken line. When you have formed your right angle triangle, then this is a right angle triangle with this symbol. Very important to mathematically represent what you are doing. Okay, now I am going to trace this line. See, if you trace it, you are going to see that you use ruler to do this. So you see where it falls, you'll find out what that line means. You also trace this line, you also see where it falls. It's what you do with ruler so that you'll be sure. Then this one too, you trace this one. You trace it until you see where it falls. You also trace this one. You already know where it falls. Now with these 4 basic lines, which one I'm going to call this one? This one is going to be T2 square. That is whatever it is here. And this is going to be T square 1. This is going to be M2. And this is going to be M1. So slope is going to be this T square 2 minus T square 1 divided by M2 minus M1. Let's do the slope here. Okay, guys, slope or sometimes they call it gradient, your slope or your gradient is going to be t squared 2 minus t squared 1 all over m2 minus m1. Okay, from your graph now, t squared 2 is at this point. So remember, this is another thing we are going to do. Can you remind me what each line here represents? I said it's 0.002. We are going to, how many lines? 1, 2, 3, 4, 5, 6, 7, 8. 8. That means 0.002 times 8. What will it give us? It will give us 0.016. Add it to 0.14 plus 0.14. You have 0.156. That is going to be T2, T squared 2, you know. So this is going to 0.156 minus. This one is at the same time as 0.04 all over. This is 120 minus, this is, remember each line here represents 2. This is 42, 44. So the slope is going to be 0.156 minus 0.04. 0.116 minus 76, which is going to be equal to 0.116 divided by 76. I'm having 1.53 times 10 raised to the power minus 3. So the vertical axis is going to be x squared all over. The horizontal axis is measured in what? Grams. This is my slope. Okay, this is the end of this lesson. Please don't forget to share this video, like and subscribe.